بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Calculus 2, Major Exam 2, Term 222. Let us solve it together and have a look. This is the first question. Determine whether the integral is convergent or divergent. Evaluate the integral if it is convergent. So this means that this integral is an improper integral. And there is no infinity or negative infinity here. So it means that this function is not continuous, maybe at the end of the interval, one of the ends, or inside the interval. This function is not continuous when the denominator is 0. The denominator is 0 when x plus 1 is 0, so when x is negative 1. So at negative 1, the function is not continuous. So we start by writing this integral from negative 1 to 15, 1 over square root, fourth root of x plus 1 dx as a limit. It is not continuous at negative 1, so we take t to negative 1 and we replace negative 1 by t to 15. And now x plus 1, I can write it to evaluate. I can write it x plus 1 to the power 1 over 4 and then take it up. So it would be x plus 1 to the power negative 1 over 4 dx. And to evaluate this integral, it would be x plus 1 to the power negative 1 over 4 plus 1, and that would be 3 over 4. So I have the limit, t goes to negative 1, and I have x plus 1 to the power negative 1 over 4 plus 1, that's 3 over 4, over 3 over 4, or multiplied by 4 over 3 from t to 15. And now this is equal to the limit. Still, we did not evaluate the limit, so we keep the limit here. There is 4 over 3. I can take it out or just leave it here. Now replace x by 15. 15 plus 1 is 16. 16 to the power 3 over 4 is 8. Okay. The fourth root of 16 is 2. 2 to the power 3 is 8. You can check by the calculator. Minus. Now I replace x by t. So I have t plus 1. And now we apply the limits. So we replace t by negative 1. When I replace t by negative 1, I'll have negative 1 plus 1, that's 0. So the answer would be 4 over 3 times 8, or 32 over 3, and the integral is convergent. Because the limit is a number, it's not infinity or negative infinity. Second question, set up but do not evaluate an integral for the length of the curve. The formula for the length of the curve is L equals integral ds, where ds is square root of 1 plus either dy by dx square or dx by dy square. Well, here he gave me that y is between negative 1 and 1, so I will use dy. And if I'm going to use dy, this means I'll use here dx by dy to the power 2. Okay, and y from negative 1 to 1. So I need dx by dy. So he gave me here y square equals ln x. Well, I need to solve this equation for x to be able to find dx by dy. So to solve it for x, I'll raise both sides to the base e. So I'll have e to the power y square equals e to the power ln x, and that's just x because e cancels ln. Now, let me find, this is x, so let me find dx by dy. So dx by dy would be, the derivative of this is e to the power y square times the derivative of y square, which is 2y. So I can write the answer from, he said setup, okay, from -1 to 1, square root of 1 plus this one, this is squared, dx over dy squared. When you square it, you can either write it 2y ey squared all to the power 2, or you just square it, so 4y squared. And when you raise e to the power y squared to the power 2, you will have e to the power 2y squared dy. So that's the answer. Set up an integral for the area of the surface generated by rotating this curve about the y-axis. Well, if the rotation is about the y-axis, then the formula of the surface area is integral 2pi x ds. And then this ds could be changed, or we can use dx or dy. He gave me that x is between 0 and pi over 2, so I'll use dx. When I use dx, I write here from 0 to pi over 2 and 2 pi x. And the definition of ds in this case would be as here, as in the previous question, 1 plus, and I'm using dx, so I'll have dy by dx to the power 2. So I need y equals, I have y equals, let me find y prime or dy by dx. The derivative of 1 is 0, the derivative of sine is cosine. So the formula would be from 0 to pi over 2, 2 pi x. Now, the integral is with respect to x, and I have x here, so that's fine. If the integral is with respect to y, for example, then I have to change x to y. Everything should be in terms of x if the integral is with respect to x. So square root of 1 plus. Now, yeah, the derivative squared is just cosine squared x dx. So this would be the answer. Write out the form of the partial fraction decomposition of this function. Do not determine the numerical values of the coefficients. Okay, we have x squared, that's a linear factor, repeated. X plus 5, linear factor, not repeated. X squared plus 3 is an irreducible quadratic factor, repeated. So this would be equal to, I need a fraction for x, I need a fraction for x squared because there is a repetition, x plus 5, the linear factor. Here I have a, here I have b, here I have c, because all of these are linear factors. X squared is a repeated linear factor. Plus, now I have x squared plus 3, so I need dx plus e, I need a linear here, linear function, plus the repetition, so I have x squared plus 3 squared. So I write another one, fx plus g, for example, okay? So this would be the decomposition, and that's the answer. Evaluate the following integrals. Well, whenever we have function multiplied by ln or ln, we use integration by parts. And we use u, we take u to be ln x, and dv the other function, which is x to the power 4 dx. Here I find the derivative. Derivative of ln x is 1 over x. And here I find the integral. The integral of x to the power 4 is x to the power 5 over 5. So this is I would be equal to uv, okay, this times this, so x to the power 5 over 5 times ln x minus integral v du, so we do like this, v du, so now I have 1 over 5 outside, okay, and x to the power 5 over x is just x to the power 4 dx. So the final answer would be x to the power 5 over 5 ln x minus. Now the integral of x to the power 4 is this one, x to the power 5 over 5. And I have 5 outside in the denominator, so I'll have 1 over 25 x to the power 5 plus c, and that's the answer. Now, the next question, integral of square root of 4 minus x squared. Well, we know that whenever we have a square root of a square minus x squared, we use substitution, trigonometric substitution. We call x, this x, we call it 2 sine theta, okay? Because this is a squared minus x squared. So we take x as square root of 4, 2 sine theta. And then we find dx. Dx would be 2, derivative of sine, 2 cosine theta, d theta. And then we check, let me call this integral also I. And let us check the square root. So square root of 4 minus x squared. Now this trigonometric substitution should enable me to get rid of the square root. So I'll have 4 minus, now x is 2 sine theta, so x squared would be 4 sine square theta. And then I can take 4 as a common factor, and I'll have 1 minus sine square theta. Okay. But 1 minus sine square theta is cosine theta, so I have 4 cosine square, cosine square theta. 1 minus sine square is cosine square. And the square root of 4 cosine square is 2 cosine theta. Of course, it could be positive or negative, but the domain, we choose the domain in which we have a positive sign here. To the square, we have 2 cosine theta. So now you can go to I and replace change from x to theta. So square root is 2 cosine theta. And dx is also 2 cosine theta d theta. So 2 times 2, I can write it outside, and I'll have square integral cosine square theta d theta. Well, how to evaluate integral of cosine square or sine square? We have formulas for that. We know that cosine square is 1 plus cosine 2 theta over 2, and if it is sine square, we have a rule 1 minus cosine square, cosine 2 theta over 2. Now I can take this 2 also outside, so 4 divided by 2 is 2, and now the integral of 1 is theta, and the integral of cosine 2 theta is sine 2 theta over 2, okay? Because we have 2 theta, so we divide by 2. That's it, okay, plus c. That's the answer, but we need to go back from theta to x. So we have here x equals 2 sine theta. So we know that sine theta is x over 2. So from here I can find theta. Theta would be sine inverse x over 2. Also from here, I can draw the rectangle of theta. Sine theta is x over 2, and sine theta is opposite, so over hypotenuse. So do I remember? X over 2, so I have this side would be, the largest is the 2, so square it 4 minus x squared, the hypotenuse square minus x squared. And if you look to the original problem, you find the same root there, okay? So the final answer would be 2 theta plus. But now sine 2 theta, I do not have 2 theta here. I have rectangle for a triangle for theta, not 2 theta. So I have to change sine 2 theta. I have to write it. We know a formula. Sine 2 theta is what? 2 sine theta cosine theta over 2. And then you can cancel this 2 with this 2, and you can write the final answer. So what is theta? Sine inverse x over 2. And sine theta is x over 2 times cosine theta. Cosine theta is adjacent k over hypotenuse. So square root 4 minus x squared, that's the adjacent over hypotenuse. So that's the final answer. You can write it x times the square root over 4, or you just keep it like this. Now, this integral, I have rational function because I have polynomial over polynomial. So I use the method of 7.4. I have to factor the denominator first. Well, I can factor the denominator by taking x squared as a common factor. So I'll have x minus 4. So I have a repeated linear here, so I can write it a over x plus b over x squared, and then plus c over x minus 4, because x minus 4 is, again, a linear factor. Okay, I have a method in my, you can go back to section 7.4, check the video there. I can find the value of b and c here easily, quickly. I can find the value of b by replacing x by 0 here. So I'll have 0 minus 12, that's negative 12. And in the denominator, I forget about x squared. I just replace here x by 0. So 0 minus 4 is negative 4. So negative 12 over negative 4, that's 3. So b is 3. Also, to find c, I replace x by 4 here in the left-hand side. So 4 minus 12, that's negative 8. And I forget about x minus 4. I replace x here by 4. 4 squared, that's 16. So in fact, this is negative half. So I have b and c. Now, to find a, I need to multiply this by the LCD, which is x squared times x minus 4. So when I multiply both sides by x squared times x minus 4, I'll get x minus 12 in the left-hand side, because I multiplied by x squared times x minus 4 equals a. This is a times. Now I multiply by x squared times x minus 4. So this x will be cancelled with one of these x's, and I'll have x times x minus 4 plus b times x squared will be cancelled with x squared, and I'll have x minus 4 plus c times x minus 4 will be cancelled with x minus 4, and I'll have c x squared. From here, I can compare the coefficients of x squared, x, and constant term, and find the values of a, b, and c again, if you like. But I have the value of b, and I have the value of c. So all what I need to find is the value of a. So I will replace x by any number I want, okay? Not 0 and 4, because I used 0 and 4. So for example, let me use 1, okay? If x is 1, what would happen? 1 minus 12, that's negative 11. 1 times minus 4, negative 3 times 1, so this is negative 3a. 1 minus 4 is negative 3b. 1 square, so this is plus a. So negative 11 would be equal to negative 3a. Now I know b is 3, so this would be negative 3 times 3, that's negative 9. And I have c, which is negative half. So negative 9 minus half, this is negative 9.5. If you take it to the other side, it would be 9.5 minus 11, so I'll have negative 1.5. So a would be 1.5 over 3, or just half. So I have the integral now. This is the integral I. The integral would be written as a over x, but I know that a is half. So half, I can write it half 1 over x, or just let me write it half over x dx. This is the first integral. Second integral, I know that b is 3 over x squared x. Okay. And I know that c is negative half. I can take the negative outside over x minus 4 dx. So that's it. The answer would be half 1 over x. The integral of 1 over x is ln absolute value of x. 3 over x squared, I'll take it up, so it would be x to the power negative 2, and the integral would be x to the power negative 1 over negative 1. So I will write it negative 1 over x, and there is a 3, so it would be negative 3 over x. And this half, I can take it outside, and the integral of 1 over x minus 4 is the ln absolute value of x minus 4 plus c, and that would be the answer of the question. The last question. Well, I have a square root here, and the derivative of ex minus 1 is not there, so there is no obvious substitution. So I have a method we learned in 7.5 to take u as square root of ex minus 1. Take the root as u, and then you raise both sides to the power 2. And then you solve this equation for x. So to solve it for x, I'll have ex equals u squared plus 1. And then taking ln of both sides, I'll have x equals ln of u squared plus 1. Why we solve it for x? To find dx, because we need to change everything from x to u. So finding dx here, what would be dx, the derivative? Well, derivative of ln is 1 over u squared plus 1 times the derivative of u squared plus 1, which is 2u. So this is dx. So now I can go to the integral and change everything from x to u. Well, I have 3, that's there. I have 2, okay, and square root is called u, and dx is 2u, okay, over u squared plus 1. I can cancel this with this, so it would be integral 3 over u squared plus 1 du, and we know the integral of 1 over u squared plus 1. It is tan inverse u plus c, and finally you can replace u by e square root of ex minus 1 plus c. Well, this is the last question. I hope you enjoyed solving this exam with me. Have a nice time, and see you back again.